mucilage incorporation in kefir as novel ingredient. Do you know chia seeds? Chia seeds are the edible seeds of flowering plant from the mint family. This plant is native to Mexico and Guatemala. The seeds have a long history. They were a vital carp in Asian, Aztec, and Mesoamerican culture. It was considered as the main food. Chia seeds are oval and gray with black and white spots and have a diameter around 2 millimeters. Composition of chia seeds is very interesting. They have a good amount of dietary fiber with a good amount of protein, with a good amount of lipid, especially omega acids, phenolic compounds, vitamin and minerals. Chia seeds have many uses. We use it in cosmetic, culinary consumption, and human organism. Health benefits of chia seeds are long. It's rich in nutrients, loaded with antioxidants. It's improved digestion because of the high amount of dietary fiber. It's good for health because of the omega-3. And it's best for pregnant women because of folic acid. What is mucilage? The chia seeds mucilage are hydrophilic. They're absorbing up 12 times their weight in liquid. When soaked, they develop a mucilaginous coating that gives them a gel texture. This mucilage is a complex carbohydrate of high molecular weight. It's an important component of the seed due to its physical role. This ingredient is high potential for food, cosmetic, and pharmaceutical application. In this work, we will focus in kefir. Kefir is fermented milk. It's similar to a thin yogurt. It's considered as probiotic. This kefir have a long history of beneficial effect. He is described as a symbiotic association of colony of yeast and lactic acid bacteria. The form of this kefir is coliform in appearance, the grain. The aim of this study is the evaluation of microbial viability at a different amount in kefir. We follow during the storage the microbial viability, the physicochemical properties, the total phenolic and the antioxidant activity. The mucilage were extracted following the protocol of Dick et al. We use 1 volume of chia grain in 30 volume of distilled water. We make the mixture for stirring. After this, we make a filtration in order to separate the gel from the seeds. After we centrifuge, after centrifugation, we dry our mucilage in ventilated oven for 10 hours at 50 degrees. The kefir was prepared using milk from Algerian market. We pasteurized this milk. After this, we added our starter culture of kefir and add the different amount of our mucilage, make the mixture to incubate in a yogurt maker. After the incubation, we store our preparation in fridge at 4 degrees for the 4 weeks of storage. We follow the microbial viability and some physicochemical analysis like a pH TTA and the syneresis. The result of the microbial viability are presented in this graph. We can show that the kefir supplemented with the mucilage have more microbial viability than the kefir control that presented in the color blue. And this microbial viability is in increase during the 2 first weeks of storage. Then after, it's decreased for the pH For the pH and the TTA, we noted a diminution of pH and an augmentation in TTA during the storage time. These three parameters, the bacterial enumeration, the pH and the TTA indicate the activity of our starter culture. The increase in bacterial colony is greater in kefir supplemented than control. This increase is due to the presence of soluble dietary fiber available in our mucilage and which promote the growth of our lactic bacteria, which induce production of greater acid, which is the cause of the increase in total tetrable acidity, accompanied with increasing in pH. These results are in agreement with our work on the enrichment of kefir with legume mucilage. The increase is in the number of bacteria over the last 2 weeks for all kefir is probably due to the presence of high concentration of acidity, which inhibit bacterial growth. Because probiotics are sensitive to certain degree of acidity. For the syneresis, we observe that this parameter is increased during the storage time, and all the samples supplemented with mucilage show lower syneresis, and this is what we're looking for. This reduction in syneresis may be associated with an increase in total solid, in particular protein and dietary fiber, which have hydrocolloidal property, which give our kefir more solid and homogeneous texture. For the extraction of phenolic, we use ethanol as a solvent. The results are shown here. We can show that the concentration of total phenolic in our kefir is increased during the 2 weeks of storage. Then they decrease. It's the same trend as microbial viability. And we can show too that there is an increase in the content of phenolic compound with an increase in the portion of added mucilage. This is attributed to the high content of polyphenol in the mucilage of Chia. The same trend is observed by Young et al. In enrichment of yogurt with different level of quinoa. For the evaluation of the antioxidant activity, the result of the PPH and the ABTS, the results are presented here. We observe an increase in the increase of the amount of incorporation of our mucilage, and the results show that the PPH radical has significant higher inhibition rate than the ABTS. Similar results have reported by other study in supplemented yogurt with rose sheep. In conclusion, the main result of this study show that the incorporation of Chia mucilage in kefir is accompanied by an increase in microbial viability with an increase in acidity and a decrease in pH. Supplemented kefir exhibited low syneresis than controlled kefir throughout the storage period. An increase in phenolic content with an increase in the rate of mucilage incorporation. It will be interesting in the future study to investigate a sensory characterization of our kefir sample, a study of mucilage structure. Also, in vitro and animal clinical study are necessary to determine health-related property of our kefir. And thank you for your attention.